Hey, 6th grade, we're going to move on, and we are going to try section 4.2, and this is with something called the greatest common factor, or the GCF. So we start off, we can find the greatest common factor by just listing the factors. For 24, that's 1, 2, 3, 4, 6, 12, and 24. For 60, it's 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Okay, well, when I look for the greatest common factor, I can see that the 12s both are. But there's another way to do that also. Okay, we can use prime factorization like we practiced in 4.1. So let's try that. We've got 24 and 60. Well, let's see, what numbers should we break 24 down into? We could say 8 times 3. So if we break 8 down, we could say 4 times 2. And we could break that down even further into 2 times 2 times 2 times 3. Okay, well, then I can also see that 60 can be broken down. Let's try 12 times 5. Well, I know we can break 12 down into 4 times 3, so let's break that down into 2 times 2 times 3 times 5. Okay, those are all now prime numbers. I can't go any farther with those. So we can see that our 2's match up. 2's match up here, and our 3's match up here. Now if we take those and you multiply, we have a quick definition, a new one that we need to add to your notebooks. Why don't you go ahead and open it up, press pause if you need to. That word is relatively prime, and that's basically when 2 or more numbers have a greatest common factor of 1. Okay, let's look at an example of a couple problems that we would use. For example, 18 and 33. Well, if I list the factors, 1, 2, 3, 6, 9, 18. If I list them for 33, they'd be 1, 3, 11. Okay, well, I can see right here that 3 is the greatest common factor. These are not relatively prime because 1 is not their greatest factor. So they are not relatively prime. Okay, we're going to take a look at the meat and potatoes of what you have to do today. So now we're going to look at the greatest common factor of monomials. Remember, monomials are just any combination when you have numbers and variables with exponents. So what we're going to do is we're going to start and we're going to break these down. We're going to factor them. So let's start with the 18xy squared. I'll start off, let's say 2 times 9 equals 18. So I've got 2 times 9. Can you break the 9 down any further? Sure. You can break it down into 3 times 3. Well, there's your prime numbers. We have an x in there. And how many y's? You guessed it, we have 2. Well, let's do the same thing with 28. Let's say 4 times 7. So let's factor that out. I can break 4 down into 2 times 2 times 7. That equals 28. And then it's x squared. So that shows me I'll need 2 x's because of the exponent is a 2. And then I also have y squared, so times y times y. Now I want to go through here and I want to see if I can find any combinations that are the same, see what they have in common. We've got 2's, we've got a set of x's, and 2 sets of y's. Okay, so I would start off writing my whole number. I've got 2 is the greatest. I've only got one x, so there will be no exponent. And then I've got 2 y's. I would write that as 2y squared, or excuse me, 2xy squared. So the greatest common factor of these two monomials would be 2xy squared. Okay, let's have you practice. Why don't you factor these two monomials? 16x and 36x. Hit pause, try and work it out, and then check your answer. Well, if I factor this out, I start off 16x, let's say 2 times 8. So I've got 2 times 8. Let's break 8 down into 2 times 4. Well then, let's break 4 down into 2 times 2. So then we've got 2 times 2 times 2. So if we multiply those all together, I should get 16. And then I've got my variable x. Let's take a look at 36x. How about we try 4 times 9? Well, I can break 4 down into 2 times 2, and I can break 9 down into 3 times 3. And then I've got times x. Okay, well, if I see my greatest common factor, I've got 2 and x. My greatest common factor would be 2x. Try these two, 18m squared and 7m. Factor the two of them and see if you can find the greatest common factor. Hit pause and then check your answer. If I factor out the 18, let's say 3 times 6. Okay, if I do 3 times 6, I know that I can break 6 down even further into 2 times 3, and I'll put that 3 in there that I multiplied it by. And then I can see that I've got 2 m's as my variables. There, I'm done with 18. 7m, well, I would say I could break that down into 1 times 7. That's a prime number, so I don't even need to list that 1. I've just got 7 times m. Well, it appears that none of my factors as whole numbers will work, but I do have one variable that's the same. M. That's my greatest common factor for these two monomials. Okay, this is the last one that I'll have you try. Factor 2x, 8x squared, and 6x cubed. Hit pause and then check your answer. Okay, I'm partway through this problem. I would factor 2x as 2 times x. I would factor 8x squared as I could break the 8 down into 2 times 4. And then I can break the 4 down into 2 times 2. And then I would break the x's down because I need 2 x's because, well, my exponent is 2. Let's see, 6x cubed, or 6x to the third power. I would break that down into 2 times 3, and then I can see that I've got 3 as my exponent, so I'll need 3 x's. So now I need to find the greatest common factor. Well, I see in all of them that I've got a 2, and I see in all of them that I have at least an x. My greatest common factor is 2x. I think you're ready to try this on your own. Okay, here's your actual assignment. You've got 4 problems that you're going to need to do. Find the greatest common factor of those 4 sets of monomials. You'll need a lined piece of paper. Make sure you put your name, the date, and for homework, this is 4.2, and this is extra credit. Make sure you label your paper with that and hand that in. Good luck.